Hello friends, this is Praveen. Welcome to online course on Python basics. We have seen how to use break, continue and pass a statement in loops. Today we will see fastest way of finding if a number is a prime number or not. So what is a prime number? Prime number is a number which is only divisible by either 1 or the number itself. So let us take how to find if a number is a prime number. To find a number is a prime or not, we will take an integer input from the user. So let us take num is equal to int. I'm just converting this to integer, and then we will use input, and then just masses enter a number to check if it is prime. It is prime or not. That's it. And once we enter it, so we know the first two prime numbers are 2 and 3, which is divisible by the number itself or 1. It is not divisible by any other number. So if the user enters 2 and 3, we can directly write these are prime numbers. So if num double equal to 2 or num double equal to 3. So we can write print, and here we'll use this as a prime number, and dot format. Sorry, let us make it here. In dot format, we will pass this num. So it will print. Now, what if for rest of the numbers? So elif, I'm putting another condition. Elif num percentage 6. So why am I using percentage 6? If you find any prime number except 2 and 3 that are either 6n plus 1 or 6n minus 1. What does this mean? That means if any number, let us make it here, any number or any prime number rather, any prime number is of the form 6n plus 1 or 6n minus 1. So what does it mean? That prime number must have remainder of either 5 or 1 when it is divided by 6. It is a necessary condition, but it is not mandatory. That it means that it is not sufficient rather. So it means that if a number is a prime number, it has to be in the form of 6n plus 1 or 6n minus 1. But it doesn't mean that a number which is of the form 6n plus 1 or 6n minus 1 will be a prime number necessarily. So this is a necessary condition but not a sufficient condition. 2 and 3, these two number are exceptions for this rule. So we will check this thing. That is why I'm using this condition. So I will put this just above here. So this any prime number is of the form 6n plus 1. So num percentage 6 double equal to 5 or num percentage 6 double equal to 1. Then only we will check if the number is a prime number or not. Right now I'm not doing any coding for this section. So what we will do, we will use pass keyword, pass, so that it doesn't throw any error and it works perfectly. If you don't know how to use pass, then you can see my previous video on this break, continue, and pass statement. So pass, and then we'll use else, and then we can directly print the numbers are not prime number. Number is not prime number. And then we'll use format and then num. So what I'm doing here, we have not written a single line of a statement or statement within this elif. Still we can check about 67% of the numbers if it is not a prime number. So let us take it here. I'm just running this code, execute. So I will take 158. So 150 is not a prime number. So I'm just checking another one, 157. So it is not returning. Why? Because if you check the remainder, 157 divided by point, or here, we can check here, point 157 percentage 6. So it is 1. So it comes into this, and we have not written any statement within this elif part, so it is not returning anything. So I will check another number for another number. So I will check 167. So how it 169 rather. So again it is coming to same thing, I guess. 169 percentage 6. So 1. So that's why it is not showing anything. 171 rather. So I'll pass 171 now. 171. 171. We can say 171 is not a prime number, and we have not executed a single loop statement right now. So almost 67% of numbers we can get that these are not a prime number. Now for rest of the 33%, we will check, we'll come to this part, and we can we'll check about you by using loop statement or for loop, or we can use while loop. So now we'll comment this pass and we will use for loop. So how long we will iterate, or how long we will check if the number is divisible or not. So a number, suppose it is a number 64. Suppose I'm writing here. So 64. So 64 is equal to 8 star 8. So what happens if we increase this number 8 to 9, and if anyhow we want to get the 64, then star, the second number has to be less than 8, then only it will come to 64. It will never go beyond this 8. So what will happen if you check anything above this square root of the number, then it will be a redundant loop. So we have to check to only square root of the number. Second thing, that if the number is an even number, so it is not a it is not a uh, prime number. So we don't have to check for the even numbers within this square root of the number. So what we will do, we will use here for for I in range, I in range, I in range. So here what we will use, the first number, because we know that our even number is not going to be a prime number. So we'll start from 3 comma, and then the last number till when we want to execute our loop to check if the number is a prime number, we'll use this num and double star 0.5. So this will return the square root of the number, and then we'll check for only odd values. We won't check for the even values, because when it is even, then it has to be divisible by 2, so it will not be a prime number. And then we'll check 2, and then we'll check the divisibility. So if num percentage I double equal to 0, so if the number is divisible by I at any iteration, then the number is not a prime number. So what we will do here, we will just print it's not a, so just copy and paste it here. And once we find that it is divisible by some number, so we don't need to go for further iteration. We can come out of the loop immediately. So what we will do, we will print here. We can use this break. So we'll come out of the loop. What if the number is not divisible by num? So in the else part, what we can do, we don't want to code anything, so we can use this continue. So continue. So what will happen if at any number this num is not divisible by I, or the remainder is not 0, then it will come to the else part, and here in the else part we are not doing, we are not executing anything. We'll simply go for the next iteration. So this continue works like that, and finally we will use else for the loop. So if it doesn't find any factor or any number within this square root of the given number, so that means that number is a prime number. So we can print here, we just use this number, control V. So that's it, this is a prime number. So let us take it here now. So what is happening here, now we'll enter some number here. So we know 37 is a prime number. So we'll check it here. So 37 is a prime number, and it is 6n plus 1. You can check 6 multiplied by 6, 36 plus 1. So it is a 6n plus 1. What if we try to use 29? We know 29 is also a prime number. 29 is a prime number. What if we want to execute it again for 31? 31 is also a prime number. 31 is a prime number. And now I will use some bigger number, and you will see how it returns immediately the output. 1001 is not a prime number because it is not checking, going to the loop for most of the numbers, for 67% of numbers. So by using this, we can find 67% of numbers without actually running loop, that it is not a prime number. And for rest of the numbers, we just have to execute the loop statements for all odd values up to only square root of the number, in first case to find if the number is prime or not. So in my next video, I will be discussing some of the real-time examples like Fibonacci series, or we will be printing some diamond pattern. So thank you for watching the video. If you liked the video, then please like, subscribe and share it.